Good afternoon, everybody. Welcome to Monday, the last week of Chem 170 in the summer of 2022. All right, let me remind you, tonight or this afternoon, after lecture, I will be sending out the password for test 4. You have until tomorrow, 5 p.m. to upload test number 4 answers to D2L as a single PDF file. Again, today after class, and we're going to end a little early. I've been pushing you guys hard on lab days. Usually I let people out early in the fall and spring, but summer, to keep on track, I used a lot of that time and it went well. All right, what I'm going to do today is, first of all, remind you again, a couple of things. One, I sent out an email for a lab amnesty, got until Friday, I think 11 or 12, whatever, to upload all labs from the past. I opened up all of them, and you can download and fill them out and go back and look at the videos if you need help and have them in. You don't want to lose all those points if you don't have labs in. Next, sometime today, I think, or tomorrow morning, sometime tomorrow morning, today or tomorrow, I will upload the last 2 labs. I got behind the little labs, and except for the one due tomorrow, they should be all caught up. Also, the lab tomorrow, I need it by Friday, because that's when I'm going to do final grading. And by Saturday morning, I should have the grades in the system. I guarantee by Sunday, 3 p.m., they will be, both in D2L and the college's system. All right, let's talk about the final. This Thursday at 2 p.m., we will not have lecture on Zoom because it's a final. And I will send out a password for the final. You'll be able to download it. I think I'll open it up Tuesday. It's password protect. I hope that works. And you'll have a couple hours take. Usually when I give it face-to-face, that's similar type final. Most students are done within an hour, 15 minutes, an hour and a half. And let's take a look at it. All right, thumbs up, people. Can everybody see final exam information on your screen? Thank you, Hannah. All right, now, final will be this Thursday at 2, thank you, Boris, too. At 2 p.m., I will send out the password for the PDF file for the final exam. You'll be able to download it. I probably will make it Tuesday or something, whatever. You'll have until Friday morning, 11 a.m., no exception unless you talk to me, but you really got to get it in because I got to get it graded. And it's going to take me a long time. But instead of using multiple choice, which are not fair to students and I hate with a passion, I've given myself the luxury of allowing myself extra time to grade your test. A lot of extra time for this one. And please notice they give you up to 3 hours. And that's not counting scanning it and uploading it. Most students are done in 75 to 90 minutes, an hour and a quarter, hour and a half. Even though I give them, and more face-to-face, I tell them, you can do it in 2 hours, but I'll give you more. All right, breakdown. Final has 32 problems, 18 pages. Some of the problems are multiple part. In 170, I've never put a multiple choice question on a test or final, and I never will. All right, point breaks down. General knowledge, 30. Nomenclature, 62. Remember, nomenclature, the 2 main types are give the IUPAC name of this molecule, and the other nomenclature is here's a name, draw the molecule. And that can be both common and IUPAC. Next, reactions, 118, because if you look back at the semester, I spent the bulk of our time after the first test on reactions. because that's where the fun is. And there are two types of reactions. The bulk of those 118 will be give the organic product or products for the following. There'll be a handful, and I don't remember how many exactly, synthesis problems, give the starting material. Now, another way to break it down is on test one, there'll be 35 points. Why that? Well, I'm not going to ask you how many carbons are in the longest chain because you need that for nomenclature and other tests, and you know how to do that. Next, test two will be 60 points. Test three, 58. Test four, 53. New material, proteins, and amino acids, 4 points. It adds up to 210. That's 10 bonus points. And therefore, that will be that. I recommend, I said on Wednesday, I probably will do it earlier. If you have any questions while you're taking it, email me on the final exam. I'll be checking every once in a while. I guarantee by Sunday, 3 p.m., if not earlier, that all your points and your final exam, final course grade will be in D2L. I'll send out an announcement when that's posted. Also in, what is it, My Access or ECC Access, I'll put the grades in. Sometimes it takes up to 24 hours or more for it to actually officially the grade you see from the ECC, but the grade you'll see in D2L will be your final grade. Now, a couple important things. One, if any student is within 10, 15 points of a cutoff, I immediately go back and regrade the whole final to make sure I didn't make a mistake. I do not send out for the final exam how many points for each question you got, just like in face-to-face after the final, I never hand it back. Students don't see it again unless they contest their grade and I bring it in. That's never happened. And that's the first thing. Next thing, think of the final as like 2 hourly tests together, point-wise. 18 pages are all our tests are usually, except for the first one, been 9 pages. And it's sort of like double, not really, but sort of. And students normally, out of 210 points, it's usually about 170 to 180 points is the average for the class. That's like an hourly exam average of 85, 90. So students do good on my final. The test questions will be just like the type you've seen on all, or the final exam, like you've seen all semester, just like the practice problems. Except, am I going to take the same ones off the test? No. But then again, do I use the same ones from the practice problems? No, but similar. Now, the best way to study for 2 things. Come to class and watch the video today, tomorrow, and Wednesday, because I'm going to do a whole semester review. Yep. And I do that all the time, and it helps students a lot. Next, use your hourly exams as practice problems. The type of practice problems I had throughout the semester and my own practice problems were very similar to what's on the test, which will be similar to what's on the final exam. And the last thing, look at the reviews. I've gone, and over the weekend, boy, this has been a busy weekend for Dr. White. I had tests from the other, I had labs. I also had a tooth removed, ouch. But yeah, Friday and Saturday morning were shot for obvious reasons, or a good part of Friday. I was just under the weather, so to speak. Even though you need a great dentist, I found one in Palatine. Let me know and I'll give you his name. He's young, he won't retire on me. And he's really, I mean, really good, and so is the staff. All right. But look at the reviews. The reviews have the reactions you should know and help show you the nomenclature you should know. All right, any questions about the final exam? The extra credit. I made a mistake and the extra credit, whoops, that's not what I wanted to do. The extra credit, I put the wrong thing in D2L. I'll give you until the 20th. So you got an extra 2 days to finish it. Remember, it's optional, but it's 10 bonus points if you do it. And before you hand it in, email me your chart and I'll check it and tell you what's wrong, things you got to change. And common things are wrong. One of the most common is people put down inorganic things, and this is organic chemistry. You have to have organic molecules. If it doesn't have any carbons in it, and also sodium bicarbonate and sodium carbonate, that's inorganic. All right, other questions? All right, the labs, I think I extended that till Friday. Hold on, let's find out. All right, Jimmy, do you see on your screen Chem 170 lab amnesty? Yep, I gave you till Friday, 11 a.m. to get any lab submitted. If it's late, I will detect 1 point, but would you rather get 0 or 10 if you got it all right, as opposed to 11? I'd rather get to 10 than 0. All right, any other questions? Oh, nice. All right, you're welcome. All right, let's go into the review. And what I'm going to do is a more extended review. This will help you. All right, everybody see test number 1 review by me, Dr. Kenneth B. White, on your screen. Give me a thumbs up if you can see it. Thank you, Jimmy. All right, things you should know, and let me make this a little larger. All right, we started out the semester talking about hydrocarbons. You should know, what is a hydrocarbon? Now, hydrocarbon is a molecule with only carbon and hydrogen atoms. There are 2 types of hydrocarbons. You should know that a saturated hydrocarbon are molecules with only carbon and hydrogen atoms, in which all carbon-carbon bonds are single bonds. By the way, commercial for Dr. White. If you're not here today, watch the video for this. This will help you for the final exam and the commercial. All right, so saturated hydrocarbon molecules with only carbon and hydrogen atoms, which all carbon-carbon bonds are single bonds. Unsaturated hydrocarbons, molecules with only carbon and hydrogen atoms, that's what a hydrocarbon is, and that contain 1 or more carbon-carbon multiple bonds, meaning it contains either a double or triple bond. Now, I won't ask about alkanes or cycloalkanes, but I use the terminology, so you should be familiar with it. All right, now we went through, and by now it's pretty old hat, how to draw alkanes and cycloalkanes. And let me remind you, your biggest friend on the final, and test number 4 later today, how many bonds to carbon? 4. How many bonds to carbon? 4. If I look at it, a lot of the wrong answers this semester and last semester and others on the final 2 in the past, if a student had looked, wait a second, that carbon has 5 bonds to it. That can't be right. Or it only has 3 bonds. That can't be right. When you're changing something, look and make sure there's 4, 4, 4. See, even on this hand, it's 4 bonds to carbon. Ooh, I can do it in stereo. 4 bonds to carbon. Remember that. Use that to check your answers. All right, now, I talked about IUPAC, which is the official name, International Union of Pure Applied Chemistry, which I'll never ask on the final. But you should know the rules. The first one is how to identify the longest chain, and you've done that already, you learned it all semester. And then there are the alkane names for the longest chains. And that's 1 through 10, methane through decade. 5 is pentane, 7 heptane, 8 octane. Now, you should know the key alkyl groups. 1 carbon CH3 on something is called a methyl group. 2 carbon CH3CH2 ethyl group. Next, if you have 3 carbons, you have 2 possibilities. If the N carbon of this alkyl group substituent is attached to a ring or chain, we call that N-propyl. If the center carbon of that 3 carbon substituent is to the ring or chain, we call that isopropyl. I only taught 2 of the 3 butyl. There's another one which I've never really encountered in all my years in industry. Nobody uses it. But anyways, if you have 4 carbons and the N carbon is bonded to a ring or chain, that's N-butyl. If you have 4 carbons and the center carbon is attached to a ring or chain, that's tert or T-butyl. And by now, you know, organic chemists are lazy, and I use T-butyl like every other organic chemist. All right, time to let you have some fun. All right, what would be the IUPAC name for this molecule? Your turn. And Jimmy, since it's you and me, give me a thumbs up when you're done. Oh, wait, Jordan's here too. Hi, Jordan. Jordan, when you have a chance, go back and look at the first 30 minutes of today's lecture on the videotape that I'll post later today. Right now, we're doing review material for test number 1. And when you're done, give me a thumbs up. Thank you, Jimmy. All right, Jordan, you're done too, so let's get going. All right, what's the longest chain? I don't know. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This would be 9. This would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, I made a mistake. I should have done something a little differently. Let's assume the longest chain is 10. And this is the longest chain. This is one of those gray areas. But let's assume it's 10. So the root name for 10 is decane. Then we have a methyl, ethyl, a second methyl. So we always start from the end. Never students try and start from this carbon. No, always from the end of a chain you start. And you number it to give the lowest numbers. Notice on carbon 3, I have an ethyl. Then on carbon 2 and 5, I have 2 methyl groups, one on each of those carbons. So 2, we say di, and CH3, oh, it's your old friend, the methyl. So that'd be 3-ethyl, 2,5-dimethyl decane. Let's try another one. Oops, I'm going the wrong way. I'm ahead of myself. And why don't you do this one? Give the IUPAC name for the following molecule. And give me a thumbs up when you're done. And a commercial from Dr. White. If you know anybody who needs a 1-semester organic this fall, I'll be teaching it online at ECC. And anybody who needs it can be anywhere in the world as long as they have internet access. So if you know anybody who needs a 1-semester like now, but it'll be in the fall, a little more stretched out, let them know they should sign up and register for my class. And give me a thumbs up when you're done. Thank you, Jimmy. Thank you, Boris. And thank you, Jordan. Gentlemen, thank you. All right, let's do this. What do we have? A ring. How many carbons? 1, 2, 3, 4, 5, 6. And that would be hexane, but it's a ring cyclohexane. On the final exam and test number 1, I saw it. Don't forget the cyclo. If you put down hexane, I'm going to mark it wrong. Then on carbon 1, I have a T-butyl. Carbon 2, I have an propyl. If you put down tert, that's okay. Now, since I'm not holding you to that IUPAC numbering or alphabet rule on a ring for cyclohexane for the cycloalkanes, you could have also put down 2 N-propyl, 1 tert-butyl. You could put 2 tert-butyl, 1 N-propyl with the tert-butyl first or the tert-butyl. So I'd accept 4 answers, even though this is the only right one. Now, there's a question. Unfortunately, Boris, no. At all the schools, I've just done the 1 semester. So I've how should I say this? When I was in grad school, I TA'd it, was a teaching assistant for that. So I know how to teach it. The opportunity and certain financial benefits were for me to just teach the 1 semester. All right, now there's 2 types of nomenclature questions. And the one is, here's the structure, give the IUPAC name. And the other one is draw the structure for, and here why don't you try this one? Draw 3-methyl octane. Don't forget, tomorrow afternoon will be the last lab of the semester. Wow, the summer went boom. And when you're done, give me a thumbs up. All right, 2 of you are done. We'll wait for number 3. And it's time to get going. All right, how do you determine what to draw? You start from the right and go left. Octane, 8 carbons. Then on carbon 3, oh, it's your old friend, the methyl. Now you can start from either end. Most of you are going to do here. And there are 4 bonds to carbon, so I know how to put in the hydrogens. And that's how you do it. Let's do one more. And there you go, 1,1-diethyl 2-isopropyl cyclopentane. That was a mouthful. Draw the structure, gentlemen. Thank you, Jimmy. Thank you, Jordan. All right, let's get going because the clock is ticking. Actually, I don't think I have a clock in my house that ticks anymore. They're all electronic. All right, how do you decode this? Know what to draw? You start here, and pentane, 5 carbons, cyclopentane, a ring with 5 carbons. And on carbon 2 is an isopropyl group. Ooh, di. That means two ethyls. They're both on carbon 1. So I'll call this carbon 1 because most of you would. Any carbon you could call 1. And I have my 2 ethyl groups. And over here, I have my isopropyl group. And that would be 1,1 diethyl 2 isopropyl cyclopentane. And that's how you do it. Now, I asked for real world uses. And if you remember on test number 1, I asked, give an example of an alkane in your daily life. That could be natural gas, methane, propane for your barbecue, gasoline, Vaseline, baby oil, or candles. They all contain alkanes. Now, there's only one reaction I asked you to learn, and that was combustion. If you take an alkane, and you can also have here and you react it with oxygen, you need a little heat source or a spark, it'll combust, burn, and you'll get carbon dioxide, water, and heat. And I showed you on test 1, had a big scary molecule. Well, if you knew it was only an alkane, it wasn't scary, it was big. And when you react it with oxygen, you get CO2 and water. All right, let's move on. Next, I talked about alkenes, double bonds, alkynes, triple bonds. And you should know an alkene has a pi bond and a sigma bond. An alkyne triple bond has 2 pi bonds and a sigma bond. Now, to name them, the double bond, find the longest chain with both carbons of the double bond, name it as an alkane. Drop the ane ending and put in ene. Now you need a number if it's acyclic, not in a ring, which carbon is closest to the end of the chain of the 2 carbons of double bond. I always get lowest possible number. Then I'll talk about it in a second. If needed, use cis or trans. When it's in a ring, no number, because one of the carbons of the double bond is always 1, the other is 2. And you don't need cis or trans. And for a triple bond, find the longest chain. In my class, you're not going to see a ring and a triple bond. But anyways, find the longest chain with both carbons of triple bond, name it as an alkane, drop the an ending, put in en. Oh, that's a mistake. That should be yne. Yeah. Yne and a number, no cis or trans. Both are 2-butane. This is cis, because the hydrogens are on the same side as a plane. And here they're on opposite sides, and that's trans. And why don't you give the IUPAC name for the following molecule? 3 points each. And don't forget, after test 4 today, go back and look at the video so you can practice. Same thing for tomorrow and Wednesday. Thank you, Boris. Thank you, Jordan. And Jimmy's done too. Thank you. All right. Look for what's different, what's not. And from now on, and I've been teaching this all semester, you look at a molecule, look for what's different. What's not carbon, what's not hydrogen, what's not a carbon-carbon single bond. Should get your attention. Wait, I got to do it like that. All right, double bond. Alkene, how many carbons longest chain? 1, 2. With both carbons double bond, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is no name. Drop the ANE ending, put in ENE, and 1, 2, 3, 4, 5, 6. We want the other way, it'd be 1, 2, 3, 4, 5, 6, 7, which is smaller, 3 or 4, or 6 or 7, hopefully a big 3 or 4. The lead carbon closest to the end of the chain, the double bond is carbon 3, 3 known ene. And notice if I had a plane there, like my finger on the screen, which you can't see, I do it in the board, but I can do the dotted line. The hydrogens are above and below that, and opposite we call trans, same side cis, and then on carbon 6 is a methyl group. So 6-methyl trans 3 known ene. And that's how you do it. Again, find the longest chain with both carbons double bond, name it as an alkane, drop the ANE ending, put ENE for double bond. What carbon of double bond is close to the chain? Carbon 3. Are there hydrogens, one on each carbon? Are they on the same or opposite side of a plane? Or both on the same, opposite trans, same cis? and carbon 6 is a methyl group. If I look at the time, it's time to take a 5-minute break, gentlemen. I will see you in 5 minutes. Hopefully some of our ladies will show up today too. With that, I'll see you in 5 minutes at 2:56. Time to get back to work. All right. We were talking about, alkanes, alkenes, and alkynes. And let's look at triple bonds. Remember, double bond has one pi bond, one sigma. Triple bond, two pi bonds, one sigma. And why don't you, gentlemen, can you see the structure I just drew on your screen, my screen? Okay, thank you, Jordan. Give the IUPAC name for that molecule. 3 points each. And when you're done, give me a thumbs up. All right, thank you, Jordan. Jimmy, thank you. Thank you, Boris. All right, what's different? Ooh, a triple bond. How many carbons long is chain with triple bond? 1, 2, 3, 4, 5, 6, 7. Or the other way, 7. 7 is heptane. Triple bond, drop the ANE, put YNE. And what carbon is that? 1, 2. So it's 2-heptine. And then 3, 4, 5, 6. On carbon 6 is your good buddy, the methyl group. 6-methyl 2-heptine. Now, let's get some reactions. Now, I taught you about reactions. In general, in organic chemistry, there's certain general reactions or functional group reactions that are like the roadmaps to tell you where to get to. And this section, we had a couple. First one was halogenation. If you take a double bond reactor with hydrogen catalyst, you break the pi bond, and each carbon of the double bond gets a hydrogen. Catalyst can be nickel, platinum, or palladium. and to your turn, and I'll help you out. And give the organic product or products for the following reaction. Thank you, Boris. Thank you, Jimmy. All right, let's get going because we got a lot to cover today. What's different? Double bond, hydrogen and catalyst. You break the pi bond and each carbon gets a hydrogen. You break carbon-carbon single bond? No. So I have 1, 2, 3, 4, 5 across. I'm going to end up with 5 across. I have a methyl group. Here are my 2 carbons of the double bond. Each one gets a hydrogen. I know there are 4 bonds to carbon. And that's how you do it. Now, the next reaction, not me, is double bond, halogen gas. You break the pi bond and each atom gets a halogen. That can be fluorine, chlorine, bromine, or iodine. And I'm going to skip that because I want to go to the next one and practice that. Now, if you take a double bond and you add to that something unsymmetrical, in the case of HX, where X can be chlorine, bromine, or iodine, one carbon gets the H, the other gets the X, and it follows Markov-Nikov's rule, M's rule. And what is that? The carbon of the double bond with the most hydrogens gets the hydrogen, and the other carbon gets the halogen. And why don't you try this one? What would be the organic product or product for the following question for the following reaction. Thank you, Jordan. Thank you, Boris. And Jimmy's done too. All right, what do we have? Double bond, HX. You break the pi bond, one carbon gets hydrogen, the other gets the halogen. And do you break carbon-carbon single bonds? No. So I have 3 across and 1 methyl. There are my 2 carbons of double bond. We look at this, we have to do Markov-Nichols rule, and that is this carbon has 2 hydrogens, this has 0, which is the greater number. And time's up, hopefully you pick 2. The hydrogen will go here, and the halogen will go there. In this case, the hydrogen will go there. Notice I broke the pi bond, and the halogen, which is bromine, will go on the other carbon. There are 4 bonds to carbon. And I'm done. And that's how you do it. Now, a similar reaction involves the reaction of water with acid catalyst to double bond. Think of water as HOH, and here you break the pi bond, one carbon gets H, the other gets OH, follows Markov-Nichols rule, and that is the carbon with the most hydrogens on a double bond gets the hydrogen, and this reaction, the other carbon gets the hydroxyl group, OH. Let's have some fun. And here's something to help you out. Again, give the organic product or products of the following reaction. And when you're done, give me a thumbs up. Thank you, Jimmy. And Jordan, thank you. And Boris. All right, how do we do this? Oh, look, it's a ring. Students hate rings. Mother Nature and Dr. White love rings. So we've got a double bond here. We're adding acid and water. You break the pi bond, one carbon, a double bond gets HOH, it follows Markov-Nikov's rule. The carbon's a double bond with the most hydrogen gets the H, the other gets the OH. Oh no, you can't see it. Here are two carbons, you count bonds. And that tells you, remember, 4 minus whatever is the number of hydrogens. Here it's 1, 2, 3. 4 minus 3 is 1 hydrogen. Here I have 1, 2, 3, 4. 4 minus 4, 0 hydrogens. Which is the greater number? And time's up. Hopefully you pick 1. Do you break carbon-carbon single bonds? No. So you get the methyl group still on the ring. Here are two carbons. The hydrogen goes here, but we don't show it. And the hydroxyl group goes to the other one. Now, if you have these switched, that's okay. The methyl down, the OH over here, and that's what you get. Now, if you have a triple bond, because organic chemists are lazy, and we are, we don't want to balance things if we don't have to. So we don't. Notice I have a triple bond, and it has 2 pi bonds. And for each pi bond, you need H2. But I'm going to put bracket X, letter X, then S, close bracket, meaning excess. I have all the hydrogen in the world with anything hydrogen can react with. In this case, the pi bonds. And for each pi bond, each carbon of that pi bond gets a hydrogen. 2 pi bonds, each carbon gets 2 hydrogens. Now we do the same thing with halogen. And there, if we have 2 pi bonds and we don't want to use balancing it, we use bracket excess, close bracket. That means we have all the halogen in the world to react to anything halogen can react with. In this case, it's fluorine, chlorine, and bromine, and a triple bond. All right, your turn. Give the organic product or products to the following reaction. 3 points each. Oh, this Wednesday is everybody turn on your webcam Wednesday. Did they buy it? Do you think they'll do that? It'd be nice for Dr. White. And don't forget, you can always go back and look at this video after today's test you're done with to get ready for Thursday's final. Hopefully you won't be doing that. Thank you, Boris. Thank you, Jimmy. Thank you, Jordan. All right, look at a molecule, look for what's different. What's not a carbon, what's not a hydrogen, what's not a carbon-carbon single bond. Should get your attention like this. Anyways, oh, look, a triple bond. We're reacting with halogen gas excess. You break the 2 pi bonds, and each carbon of the triple bond gets not 1, but 2 halogens. You break carbon-carbon single bonds? No. So I have 1, 2, 3, 4, 5 across. 1, 2, 3, 4, 5 across. And I have these 2 methyl groups on this carbon. Now, here are my 2 carbons of the triple bond. I broke the 2 pi bonds, they're gone. And each one gets 2 halogens. And what's that? Iodine. And there are 4 bonds to carbon, so I can put in the rest of the hydrogens. And that's how you do it. Now, I didn't mention it, but there was one common name you should know. And that's the simplest triple bond. Nobody ever calls this ethyne. I think about it. And you can write it this way or this way. Either way is correct. And you should know that. All right, next I started talking about aromatic compounds. They're called that because they originally obtained from spices and herbs. And the first one is benzene. Now, benzene is a 6-membered ring, and there are 3 ways of drawing it. The 2 resonance form with 3 double bonds conjugated, alternating single, double, single, double, single, double, or with the pi cloud circle. And if I look at this, I have this one. Wow, I got to go back and correct some of this. All right, hold on. Why am I? There we go. I so rarely use this. I didn't even notice I did the same thing. Now, if I ask on a test, draw the structure of benzene, and you do this, I'm going to mark it wrong because that's cyclohexane. There's got to be something in here, either double bonds like this, 3 of them, or a circle. This is cyclohexane without anything in there. I'll mark it wrong. So make sure you put the bonds in there. Now, when you have a methyl group on a benzene ring, we call that toluene. Now, for substituted, and methyl on toluene counts as 1 group, we use ortho 1,2 disubstituted, meta 1,3, para 1,4. At this point, I taught you some new substituents. Cl is chloro, F is fluoro, Br bromo, I is iodo, and NO2 is nitro. So let's take a spin. And why don't you give the IUPAC name for the following molecule? 3 points each. Thank you, Jimmy. Uh-oh, we lost Boris. He'll be back. Maybe. All right, let's get going. I'll give you Jordan a little while more. Thank you. All right. Ooh, methyl group on a benzene ring. That's toluene. If I can spell it. NO2 nitro. So much for drawing straight lines. But anyways, for dye substitute, ortho is 1, 2, meta is 1, 3, pure is 1, 4. I call this 1, 2, 3, 4. This would be pure nitrotoluene. And why don't you try drawing the structure for meta-T-butylchlorobenzene? Your turn. Don't forget, if you need help with anything, I have my office hour tonight from 6 to 7 on Dr. White's office hour Zoom meeting. Remember, ortho 1, 2 dye substituted, meta 1, 3, para 1, 4. And when you're done, give me a thumbs up. Well, thank you, gentlemen. The J's are done. We're waiting for the B to be done. I guess you're done too. All right. How do we decode this? Start from this way. Benzene. Cyclohexane ring. Don't forget the bonds. Then I have a chloro and a T-butyl. Meta is 1, 3. And a lot of you will probably put the T-butyl here. And then 1, 2, 3, my chloro. Now you could have easily, and all I'm doing is rotating the ring around, put the chloro there, T-butyl there. Which one of these is right? They're both. And there are other ways I can rotate the ring because that's all I'm doing, flipping it like that. All right, now let's go look at reactions of benzene ring. Now, if I take a benzene ring and react it with halogen gas and ferric trihalide, I replace one of the hydrogens with the halogen. Because of the pi electrons holding hands, they don't want to lose that stability. So what happens is one of the hydrogens in the benzene ring is replaced by something, a substitution reaction. And if the first one for halogenation will be this. Now, as I said on the final, just like on test number 1, ooh, that was on the final, like test number 1, I will only start with benzene because in this class, I just don't want to take the time to teach you directors. There are better things I'd spend time on this semester. Better for you. So if we look at the following, and it's your turn. Give the organic product or products from following reaction. And when you're done, you know what to do. Click on an emoji. It doesn't have to be thumbs up. Thank you, Jimmy. And Boris took me up. Oh, excuse me. Been a long day. All right, let's get going. What do we have here? Benzene, chlorine, ferric trichloride. That's this right here. What do? take the benzene ring and replace one of the hydrogens here, which we don't show, with a halogen. This tastes chlorine. Now, watch closely. If you had put that down, I'd mark it wrong. Why? Because this is cyclohexane. So that would be chlorocyclohexane, not chlorobenzene. Remember to put the stuff inside like this or a circle like that. One of those two, because if you don't, that's cyclohexane, and I'll mark it wrong all the time. So let's move on. All right, if you take and react it with HNO3 and sulfuric acid, you put a nitro group on there. This is the only reaction I can ask on the final. If you take, and remember, nitro is NO2. If you put NO3, I mark it wrong. Next, sulfonic acid, SO3, H2SO4 catalyst, and you put on a sulfonic acid, HO3SO3H, not O4 or just SO3. You need the hydrogen there. And that's the only reaction I can give you. And finally, a great reaction, and that's called Friedel-Crafts Alkylation. And that's where you take RX, an alkyl halide, X is chlorine or bromine, aluminum trihalide, and the carbon with the halogen is the carbon bonded to the ring at that carbon. All right, your turn. What two things do react to make this compound? And I'll help you out. And help me out. That's better looking. And your turn, gentlemen. Give the starting materials, two of them. Ooh, I'd make those 6 points, 3 each, to make that compound. Your turn. Thank you, Jordan. The reason I'm doing this is I told Some of you might have come in late on Friday. I had a tooth extracted out. Actually, it wasn't that bad, but it was swollen. It's almost gone. You need a good dentist. I know a great guy in Palatine, young guy too. In fact, he's the third generation dentist in his family. His grandfather started to practice, his father continued it, and he's continuing it. He's doing a great job. Wow, is he good? All right, everybody done? If you're done, let's do it again. Give me a thumbs up if you're done, all of you. Or any other emoji. All right. 2-2, Boris. Anyways, let's do it. What's different? Ooh, a benzene ring, but it's got an R group on it. And how do we do that? We react benzene with an alkyl halide. What's X? Remember, X can be chlorine or bromine. In this case, it's chlorine. So one of the question marks are starting materials, the benzene ring. Don't forget the bonds inside. And the other one is we have 3 carbons. The carbon bonded to the ring will be the carbon with the halogen, in this case, the center, chlorine. And there are 4 bonds to carbon. And that's how you do it. Any questions about test number 1 material? Now, to make your life just a little bit easier, don't tell anybody I'm being nice. The way I have my final set up, the first couple of pages, the first questions will be test number 1 material. Then comes test number 2 material, then 3, then 4, and at the very end, some new material on amino acids. And I think that's just easier for you as opposed to the shuffling the deck. You know, I haven't done that in a while. I haven't played cards in a while because of the pandemic. But anyways, not a big card player. Backgammon I like better, or other games. But anyways, that will help you on the final exam. All right, let me close test number 1 review and open up test number 2. Now, what will we start with? Oops, we started with, I didn't let you share it and see it. All right, thumbs up, people. Do you see? Test number 2 review by Dr. White, me. And the first thing, let's talk about alcohols. What's an alcohol? A hydroxyl group OH on a carbon. And how do you name it? Find the longest chain with the carbon with the hydroxyl group, name it as an alkane, drop the ANE, and add OL. Now, if it's acyclic, and I forgot to put this there, you need a number. What carbon has the hydroxyl group? That's always given highest priority, lowest number. If it's in a ring cyclic, then you don't need a number, and the carbon with the hydroxyl group is carbon number 1. Now, if you have a benzene ring with a OH group on it, it's called the old name, which IUPAC said, well, make that the IUPAC name too, phenol. Some people say phenol, nah, phenol. And with that, it's time to take a 5-minute break. I'll see everybody at 350. With that, I'm going to say break time. I'm back. Let's get going. We're talking about alcohols, and alcohols are molecules that have a carbon with a hydroxyl group. And remember, you find the longest chain for acyclic, drop the E, add it, name it as an alkane, drop the E, add OL. And for acyclic, you need a number, cyclic none. And let's do an example or two. And the question is, give the IUPAC name of the following. And hold on one sec, maybe 5 seconds. There, now do it. Give the IUPAC name for that molecule. Thank you, Jordan. And when you're done, don't forget that or an emoji. ANE to OL. Thank you, Boris. Thank you, Jimmy. All right, we've got to move on. So I'm going to move on. What do we do? Look for what's different. Ooh, hydroxy group on a carbon. Alcohol. And what do we do? Find the longest chain with the hydroxyl group, carbon. Drop the E, name it as an alkane. Drop the E, add OL. 1, 2, 3, 4, 5. Any way I count it, the longest chain is fine. Come with that hydroxyl group carbon, pentane. Drop the E, OL, pentanol. It's on carbon 3, 3 pentanol, and carbons 2 and 4. Oh, it's your old friend, the methyl. There are 2 of them, di, methyl. And when you have di, you need 2 numbers, and those 2 numbers are 2,4-dimethyl 3-pentanol. Now, let me remind you, this would be alcohol and a carbon, 5 carbons is pentane, but it's a ring. Remember the cyclo. And drop the E, add OL. When it's a ring, this is always going to be carbon 1, and you don't put a number there. And I didn't, and I'm done. Cyclopentanol. Now, you should practice, and I want to get through some reactions before I let you out a little early so you can start on test number 4. And that is practice. Here's the name, draw the structure. Now, we have common names. Name. How do you do that? Name the alkyl group on ROH. This is an alkyl group, and add the word alcohol at the end. Nobody calls this 2-propanol. It's isopropyl alcohol. Isopropyl group, if I could hide the OH group in a board in the class, I could, but I think I just covered this, isopropyl and alcohol. All right, now, how do you make an alcohol? Well, we just did this reaction, and that's if you take a double bond, react it with acid and water. Remember, water is HOH. To break the pi bond, one carbon gets H, the other gets OH, and it follows Markov-Nikols's rule. Now, one of the harder reactions this semester was this one. If you take a alcohol and react it with sulfuric acid, and the little triangle here means heat, and sometimes instead of putting that, I'll actually put heat. You get a double bond and follows Zasa's rule. And Zaysev's rule is to get the carbon double bond that has the most carbon atoms bonded to it. You get the double bond that has the most carbon atoms bonded to it. And I'm going to do one for you. If I get my screen back up. Now, the question is, give the organic product or product. I'm going to do this one myself because I think you could use the help. And what do we have? A carbon with a hydroxyl group and a carbon bonded to that carbon called an adjacent carbon, one next door, with a hydrogen. And when you react it with sulfuric acid and heat, you'll lose water, dehydration, and between these two carbons, you'll form a double bond, and it follows Zaysev's rule. So how do we do Zaysev's rule? Well, you look at the carbons attached to the hydroxyl group carbon, and that's this one A and this one B. Now, if I lose the hydroxyl group and a hydrogen from A, do you break carbon-carbon single bonds? No. And between these two carbons, I'll have the double bond. That's these two right here. And that's the alkene you get. Now, if I lose the hydroxyl group and the hydrogen from B, I'll get this molecule. Now, how do you use Zaysev's rule? You go and look at the two molecules and you count how many carbon atoms are directly bonded to the carbons of the double bond. In this case, 1, 2. You don't count these. So this has 2 carbon atoms. Here are my 2 carbons double bond. This one, I have 1, 2, 3. Which is the higher number? Hopefully you pick 3. Therefore, the answer is B, because that has the most carbon atoms directly bonded to the carbons of the double bond. And that's how you do Zaysev's rule. And on test number 2, I had a similar problem, and a number of you had difficulties with that. Go back and watch what I did if you had difficulties. That's my gift to you, Kent. All right, let's continue on. Now, if you have an alcohol and react it with HX, where X can be chlorine, bromine, or iodine, you replace the hydroxyl group with the halogen on the carbon that has the halogen. So let's do one. I should say, let's you do one, because I'm going to share this one with you. Oops, wrong color. and give the organic product or products for the following. And this because you may not have had a chance to study for the final, because you studied for test number 4, let me help you out. And it's your turn. Give the organic product or products for the following. Thank you, Jordan. Thank you, Jimmy. Thank you, Boris. All right, time for Dr. White to thank me. All right, what's different? What's not carbon? What's not hydrogen? Should get your attention like this. Red siren overdose today. And the answer is hydroxyl group on a carbon, and we're reacting with HBr, and that's alcohol plus hydrogen halogen acid, and you replace the hydroxyl group with the halogen on the carbon that had the hydroxyl group. You break carbon-carbon single bonds? No. So I have 1, 2, 3, 4, 5 across. 1, 2, 3, 4, 5 across. Which carbon has the halogen? That's the one going to get, or the hydroxyl group that will get the halogen, which is bromine. And there are 4 bonds to carbon. And I'm done. And let's go to the next reaction. If you take an alcohol and react it with thionyl chloride, SOCl2, you replace the hydroxyl group with a chlorine. Again, take an alcohol, react it with SOCl2, replace the hydroxyl group on the carbon that the hydroxyl group was with a chlorine. Now, the beauty of SOCl2, thionyl chloride, unlike HX, hydrohalogen acid, which will react if you have double bonds in a molecule, which won't happen in this class. Oh, excuse me, but if it does, thionyl chloride will not. And what would you react with thionyl chloride, SOCl2, to make that molecule? Your turn, because there will be a couple of synthesis problems on the final exam. Wow, it just seems like yesterday I was saying, how many bonds to carbon? 4. I just did again. I mean, this seems like not too long ago we started. Boy, did summer go. So what would be the starting material that you react with thionyl chloride to make that molecule? And don't forget, once we finish, in about 5 to 10 minutes after we finish today, I will send out the email with the password for test number 4, and you have until 5 p.m. tomorrow to upload your answers for test number 4. Thank you, Boris. Oh, no, I'm sorry. I was looking at the wrong. Thank you, Jordan. Sorry, I hope I didn't scare you, Boris. Oh, no, I brought tears to his eyes. I'm sorry. And Boris is done. Thank you. I can say that. And we'll wait for Jimmy. And he's done. All right, what's different? What's not carbon? What's not hydrogen? The product, a chlorine on a carbon. And what do we start with when we react something with thionyl chloride and alcohol? Do you break carbon-carbon single bonds? No. So if I end up in a ring with a methyl group, I better start with a ring with a methyl group. Which carbon had the halogen will be the carbon with the hydroxyl group, this one, and I'm done. And that's how you do it. Let's move on. Now, if you take an alcohol and react to oxidize it, a primary alcohol, and I'll never ask on a test what's a primary alcohol. That's 1R group on the carbon with the hydroxyl. You'll get an aldehyde. If you oxidize a secondary alcohol, you'll get a ketone. Now, tertiary gives you no reaction. And I have never, because I hate it with a passion, asked a problem, give the organic product or products, and it will never be true that the correct answer will never, ever, ever, one more, ever be no reaction. If I ask you for a product, something's going to happen. So let's take this for a spin. Remember, bracket, close, close bracket, oxidation reaction, reagent. Ugh. Now for test number 3, that was a carboxylic acid. So if I put a primary on there on the final, either one would be a correct. But let's assume it's test number 2. Your turn. What would be the product or product for the following reaction? 3 points. Thank you, Boris. Thank you, Jordan. Thank you, Jimmy. Well, I better get with the crowd. Oh, I got to do it first. All right, let's take a look at this. What's different? What's not carbon? What's not oxygen? Hydroxy group on a carbon, a primary alcohol. Why do I put that there? Because I'm oxidizing. O, bracket O, close bracket, oxidize. The carbon with the hydroxy group becomes a carbonyl carbon, carbon double bond oxygen with an H aldehyde. To break carbon-carbon single bonds, I could have said this is my R group, or I could also count 1, 2, 3 carbons. I'll end up with 3. The carbon with the hydroxyl group becomes this carbon, double bond to oxygen with a hydrogen, and that's that. Oh, excuse me. And the question is, question mark, what do you oxidize, that's bracket O, close bracket, to make that molecule? 3 points each. Thank you, Jimmy. Uh-oh, everything disappeared. I have to. Huh. All right, we're back in business with this one. All right, we're back in business. Sorry about that. Hopefully after the semester, I wanted to wait until semester. I have more memory on order, but I wanted to wait. I didn't want anything bad happening to this machine while I'm still teaching you. It works, but every once in a while it gets funky on me. All right, again, what's starting material for that reaction? If you're done, let's give a thumbs up again. Thank you, Jordan. Thank you, Jimmy. Well, wait, thank you, Boris. All right. And what's different here? What's not carbon? Whoa, a oxygen double bonded to carbon here, carbons here and here. It's a ketone. And what do we oxidize? A secondary alcohol. And the carbon with the carbonyl is the carbon with a hydroxyl group. So do we break carbon-carbon single bonds? No. So I'm still going to have this ring. I'm still going to have these two methyl groups. And the carbon here with the carbonyl will be the carbon here with the hydroxyl group. And that's how you do it. And that's the fun part of organic chemistry, but I'm biased. I'm a synthetic organic chemist. Won't ask on the final, but remember, synthesis means to make, and that's my training in my PhD and all the decades I worked in the chemical industry. All right, let's finish up with thiols, and tomorrow I'll start with ethers. And the thiol is sulfur with a hydrogen attached to a carbon. Thiol, sulfur with a hydrogen. And the most important thing, one, they stink. If you mean stink, yes, I do mean stink, like skunk odor stink. Oh, it's so stinky, I said it wrong. Ooh, that's stinky. Uh-oh, I'm in a stinky roll. I'll have to get out of it. But on a serious note, thiols are used so you can smell a natural gas leak. A thiol, T-butyl thiol, is put in natural gas. Only 4 pounds of that thiol per billion, yes, billion pounds of natural gas, methane, CH4. So you can smell that leak, and you can smell, at least I have, my lifetime real quick. And that's because you should know of the tragedy that happened in Texas in 1935, I think it was, where because of a gas leak, a school blew up, 135 or 50 students and teachers died like that, almost like that, and others were badly injured. And because of that, we now have thiols and gas to let us know if we have a leak. Now, I just looked at the clock. There's one up here, one down here, one no. But anyways, now would be a good time to stop, and we'll continue tomorrow with the review. Now, tomorrow, don't forget by 5 p.m., upload test number 4. I should have it graded by Wednesday. I better get it graded by Wednesday. On Wednesday, I will go through test number 4 answers here in the video, but I will cut it out, and we'll do some more review tomorrow. And then Wednesday, we'll do that. Tomorrow, I'll also have a lab for you, the final lab. It's a quick one, and you should be able to write it up like that. I don't know like that, but really quick. And with that, I'm going to say goodbye, gang gesund, and about 5 or so minutes, maybe up to 10 minutes, then I will send out an email with the password for test number 4. Got till tomorrow, 5 p.m. to take it, upload it as a single PDF file. If you have any problems between now and then, tonight at 6 to 7, I'll have my office hour, and then I'll check tonight every couple hours my email, and tomorrow morning early, because I got to teach at the school, or actually go face to face, got to drive there at COD, so I won't be back until right before this class. But with that, I'll say, gang gesund, be healthy. I'll see you tomorrow. Don't forget, bye, Jimmy. Don't forget, there's another strain of COVID going around that's supposed to be pretty nasty. I've always worn my mask, but now is the time to go back to wear a mask. But that's my own personal opinion. And with that, I'll say, gang gesund, goodbye. I'll see you tomorrow.